Quick summary of the registers before we move on. These are small blocks of volatile memory. Their values are lost when the power is switched off. They store temporary values and being used instructions being run by the CPU. Registers are fast and run at the same speed as the CPU. There are some registers which have a very specific purpose and are known as special purpose registers, and these include the program counter, the MAR, the MDR, and the ACC. So now let's look at the last part of this, which is the components. It's very important you don't mix up registers and components. Although the registers are part of the CPU, they're considered separately in exam questions. So when an exam question asks about a component, it's always asking about one or two things, either the ALU or the CU. The ALU, the Arithmetic Logic Unit, has the job of running all calculations. These are known as arithmetic calculations. These include adding, subtracting, multiplying, etc. It also deals with logic, which is where the logic part comes in. These are comparisons such as less than and greater than, but also logic such as and, or, and not. It also uses a special purpose register known as the accumulator to store the results of all calculations. The control unit is a bit hard to understand, so we're going to take our time when we go through these points. First of all, it's responsible for executing instructions in the correct order. So it has the responsibility of dealing with if statements and while loops and functions and all those kind of things, which in machine code are called branching or jumps. It has the job of decoding instructions. So it will actually take the binary value, decode it, work out what instruction needs to be run. It sends a regular pulse to the CPU to control timing. We don't want to start the next instruction till the previous one has finished. So the timing, which is measured in hertz, is used to make sure the CPU is always synchronized with every other part of the computer, which is obviously very important. Finally, it sends and receives control signals. Now, control signals are essentially special messages the CPU sends to other devices such as RAM or the hard drive or storage, any device that's connected to it to tell it what to do. So it's controlling it by sending these special signals. All of those signals are always sent down via the bus. So instructions run by the CPU can take different amounts of time. However, the CPU can't move on to the next instruction until a special signal is sent out, which is sent by the CU. Every set amount of time, the CU will send this pulse out to let the CPU know it can move on to the next instruction. This pulse is controlled by the clock speed of the CPU, which again is measured in hertz. The reason for this is you can think of the CPU as a great orchestra. If some of the parts of the CPU of the computer, are out of time, then it won't sound right, it won't work right, it won't work as it should do. So everything must be in sync, everything must play at the same time. And this control signal sent by the CU helps with that synchronization. So the final pause of this session, pause the video and make notes on what the role of the ALU is, and finally what the role of the CU is. It's really important you include all the detail that was in this video because that detail will come up on the exam.